I'm the business development manager and one of the co-founders of enifer, and we are a startup which was founded in 21 in Finland, and we like to say that we are proving the original mycoprotein, and you will find out in soon why is that. And currently we have 21 employees, and we just secured the funding for our first industrial 3,000 tons factory, which will be launched in 26 in Finland. And we have done also pre-engineering in a larger factory, in a 10,000 ton factory, which will be launched in 28. And even though we are quite young startup, the technological readiness level is quite high. It's about 8. And we are looking for pioneers in the aquafeed industry to develop more sustainable aquaculture with us. And why we should make mycoprotein from fungi? Well, fungi, they build new protein while growing on organic matter and minerals. For example, if you compare to insect protein, insects just concentrate existing protein, but fungi, they build new protein out of organic matter and minerals. And because the production happens in a bioreactor, in a fermenter, the production requires far less land and water than plant proteins. And the protein quality is closer to animal protein when you compare it to plant proteins. So in short, we are creating new quality protein while recycling carbon, because we can use industrial side streams as a carbon source. And this process, this specular fermentation process, it's not something that we invented in lab 2 years ago, but it has a long industrial history in Finland. This process was originally developed by the Finnish pulp and paper industry, and there were 2 industrial 10,000 tons factories running from 1975 to 1991. And actually, this was the world's first industrial mycoprotein production process, which was run in industrial scale. And since there's such a long history, 15 years, previous use as feed material, which is backed by extensive scientific data, it has been added into EU feeds material catalogue, meaning that it can be sold in European Union as a feed ingredient. And we have privileged access to the original plant data on which we base our cost and life cycle assessments. So our numbers, they are not something that are based on lab experiments, but they are based on actual industrial data from these 2 factories which were run for 15 years. And uniquely among alternative proteins, specular protein can compete on price with conventional protein sources in targeted markets. And we have been improving the process. In the previous old factories, the protein content of the product was about 50%, but we have managed to raise the protein content into 65%, and we have filed 3 patents on this. And since the protein content is now higher, we can use it in, for example, in salmon feed. And we have been also expanding the range of industrial side streams that can be used as raw materials in the process. And we have found out that the largest potential is in bioethanol production side streams. And Pekilo protein, it can be used as a drop-in ingredient in fish feed production. It has been tested in fish feed extrusion processes, and it works as good as soy protein concentrate. And besides being a high protein ingredient, Pekilo protein has about 15% of fungal beta-glucan and 10% of nucleotides. So it's not just a protein ingredient, there are added benefits. And the palatability of the product is excellent. The researchers performing these salmon feed trials on Pekilo protein have said that the salmon liked Pekilo feed immediately. They didn't need time to get used to the taste at all. And if you compare the composition of the Pekilo protein into krill meal, we can see that Pekilo Aqua, which is the commercial name for the product, has more protein and nucleotides than krill meal. And in my understanding, nucleotides are quite important in the palatability. If you compare the amino acid profile of Pekilo protein into soy protein concentrate, you can see that it is quite similar to the soy protein concentrate, but there are a little bit more of the most important amino acids, lysine and methionine. So besides being a good source of lysine and methionine and other amino acids, there is a lot of nucleotides and beta-glucan, and high nucleotide content is associated with growth and health benefits. And fungal beta-glucan is known to enhance the immune system in fish. And currently both of these compounds are separately added in specialty aqua feeds. We have performed 2 digestibility trials in Atlantic salmon, 2 trials in rainbow trout, and 1 in shrimp. And growth trials, 2 in Atlantic salmon, 1 in rainbow trout, and 1 in shrimp. And the digestibility of the product has been in the range of 85 to 88.6%. And we have seen improved feed conversion ratio and growth with the increasing inclusion. And the latest trial was performed on juvenile Atlantic salmon, and this trial was done in Norwegian University eniferBio. And this group was led by Professor Margaret Överland. And from these charts, you can see that there was a trend towards increased feed intake and growth rate when you included the Pekilo protein in the diet. And in the highest inclusion diet, there was a statistically significant improvement of feed conversion ratio, which is very good thing. And the reason for this was the improvement of the gut health of the salmon. And from this chart, you can see that goblet cells and gut willy height were improved, even in the smallest inclusion rate, in the 5% inclusion. And the improvement in goblet cells was made by the beta-glucan, and the improvement in gut willy height was done by the high nucleotide content. And when you consider the carbon footprint of fish feed protein ingredients, they are very important when you consider fish farming's carbon footprint in large scale. And Pekilo protein's carbon footprint is 1.5, and it's quite low compared to Brazilian soy. And currently we are able to supply sample batches, and the product can be sold in the European Union and in UK and in Thailand. And we are expecting commercial launch in 26 when our first plant is running in Finland. And we've also done pre-engineering on a larger scale factory. And the price of the product will be about 3 euros per kilo at the time of launch, and we target the price of 1.5 to 2 euros per kilo when the process is scaled up into 10,000 tons. And this factory is probably running in 27 in France. Thank you.